Welcome to Lesson 03 of Ubuntu Mastery, the one where we stop guessing and start owning who can do what on the box. Permissions aren't intuitive, but they're learnable, and every lesson after this one assumes you've got them down. We'll walk the user model, harden sudo beyond the install time default, scale with groups, decode file permissions in octal and symbolic, and reach for POSIX ACLs when groups run out of road. Get this wrong, and root by mistake becomes routine. Get it right, and your blast radius is bounded. Start with the user model, because everything downstream, sudo, groups, file ownership, keys off of it. Ubuntu sorts accounts into 3 buckets by UID range. 1 to 99 is historical core, root, daemon, bin, kernel, and glib territory, hands off. 100 through 999 is system users, created by package installs. That's your www data, your Postgres, your system resolve, almost always with a Nulligan shell. 1000 and up is humans, with a real home directory, a real shell, and maybe sudo. Memorize the ranges, and why does nginx own chuvare www stops being a mystery. Now that you know who's who, let's manage them. Ubuntu gives you 2 tool chains. Aduser is the friendly Perl wrapper, interactive, prompts for password and geekos, handles, jush, etc., skell for you. Useradd is the POSIX primitive, terse, scriptable, what you reach for in Ansible. Use Aduser at the keyboard, useradd in automation. And one critical reflex on usermod, always pass -i with -g, or you'll silently wipe every existing group membership. Offboarding is the part most teams botch. Lock the password, delete authorized ORNT keys immediately, then deluser with a backup. Forget the SSH key and that engineer keeps their shell forever. Once users exist, the next question is what they can do. The Ubuntu default, anyone in the sudo group gets full root with a password, works on a laptop and falls apart across a fleet. Production policy is layered. Harden the defaults with secure path, lecture, and log input. Split roles into seam and yarn aliases so DevOps, NetOps, and read-only each get exactly what they need, and reserve no passwd for narrow automation whitelists, never humans. And the iron rule, always visudo-f into etc. sudoers.d, never touch etc. sudoers directly. One syntax error there, and you've locked yourself out of root. Granting sudo is only half the job. Auditing it is the other half. Every invocation lands in var log auth.log with username, tty working directory, and the exact command. Learn 3 queries cold, all sudo activity in the last 24 hours, failed attempts and not in sudoers lines for privilege escalation probes, and a frequency count to spot the human commands hiding in the automation noise, and ship auth.log off box via rswicelog. Because a compromised host that can rewrite its own audit trail has no audit trail. Once auditing is in place, the next question is scale. You don't grant permissions to 50 users one by one. You grant them to groups and assign users in. Ubuntu ships the ones you need to recognize on site, sudo for privilege, ADM for log reading, www data for web servers, and Docker, which is root equivalent, so treat membership accordingly. Layer your own on top, DevOps, DBA, support, and burn this into muscle memory. Usermod always takes -lowercase-a with -G. Without the -a, you replace every secondary group the user had, including sudo. That's how people lock themselves out at 2 a.m. Groups decide who belongs. Permissions decide what they can do. Memorize the math. Read is 4, write is 2, execute is 1, per category. 0.75 for scripts, 0.644 for normal files, 0.600 for secrets. SSH keys, .nv, anything you be fired for leaking. The special bits are the trapdoors. Set gid on a shared directory makes every new file inherit the group. That's how Josh SRV DevOps actually works for a team. Sticky on TMP keeps users from deleting each other's files. And setuid, audit it monthly with find-perm-4000. A new setuid binary you didn't put there is not a feature. It's a compromise. Eventually, the 9-bit model breaks. The moment you need 3 groups with different access plus one specific user, user group other can't express it. That's where POSIX ACLs come in, and Ubuntu's XT4 mounts them by default. Use setFaceCL-M to add a named entry, -dm to make it a default that new files inherit, and getFaceCL to inspect. Watch for the plus sign on ls-l. dar wxr x plus means an ACL is in play. If you don't see it, you're reading an incomplete picture of who can touch that file. Theory's done. Here's the cheat sheet that covers 90% of what you'll actually configure. SSH directories need 700, key 600, or SSHD silently rejects them with no useful log. Sudoers drops at 0440. Web roots run 755 with 775 plus the www data group on upload directories. Shared team diars get 2-705. That setgid bit is what makes new files inherit the group instead of breaking collaboration overnight. Rule of thumb: when something fails silently, check permissions first. It's almost always permissions. Now the gotchas, 5 permission mistakes that have ended careers, or at least weekends. Number 1, user mod -G without -A replaces every secondary group instead of appending. Run it on yourself and you're out of sudo on next login. 2, SSH keys with loose perms get silently rejected. No error, just a password prompt. 3, edit sudoers with vim instead of vsudo, save a typo, and you've locked the whole system out. 4, the Docker group is root equivalent. Anyone in it can mount the host file system and read everything. 5, setuid binaries owned by app users are a privilege escalation gift waiting for an exploit. Audit them monthly with find-perm-4000. So that's lesson 3 and 6 moves. You can model users across the 3 UID ranges, run the full lifecycle from user add to clean offboarding, write sudoers that survive an audit, trace every privileged action through auth.log, layer groups and ACLs for real-world sharing, and reach for setgid, sticky, and setuid only when you actually need them. That's the access foundation. Next lesson, we go one layer down: file system hierarchy, fstab, and storage, the ground these permissions sit on. Lesson 3 is closed. Access is controlled. Users, sudo, groups, ACLs, and the special bits are all in your hands now. Next up, the ground underneath: file system hierarchy, fstab options that save you at boot, disk usage triage, and the quota and inode pressure problems that bite in production. Load lesson 4 when you're ready.